Okay, guys, let's do some factoring. Well, what's our first rule? Look for the GCF. Sure enough, there's a GCF in A of x to the third. So I'll factor out the GCF, and I'm left with x squared plus 13x plus 30. Now notice it says factor completely. This part can be factored again. So I now have x to the third, and now I'll have my two sets of parentheses for the trinomial. I have x and x. Since it's positive, and this is positive, these both must be positive. But I need something that the outer and the inner together will add to 13. That would be 10 and 3. 10 times 3 is 30. 3x plus 10x is 13x. Here's another trinomial. Check for the GCF. No, there's not a GCF, so I can just go ahead and start factoring. X and x. And now I need to get negative 15. So I'm going to have to try one of these has to be positive and one has to be negative, because positive times negative gives me negative. So what multiplies to 15? Probably I'd start with numbers in the middle, like 5 and 3. So then I need to figure out, should this be the 5 or should this be the 5? Which spot? This will actually work if I make it negative 5 plus 3x. Why? Because the outer is then negative 5x, the inner is then positive 3x, and together they add to negative 2x, which is what we wanted. This is a cubic. So I'm going to go ahead and use the cubic factoring. Let's write that down. X to the third minus y to the third is x minus y, x squared plus xy plus y squared. So now I'm going to take my original problem and write it x to the third minus, well, 8 could be written as what number to the third? 2, because 2 to the third times 2 is 8. Now I'm just going to go ahead and fill in x minus 2 x squared plus y is 2, so this is, instead of xy, it's y squared. 2 squared is 4. That's your complete answer. Step 1, check for the GCF. No, there isn't one. So I'm going to factor it as a trinomial. To get the first of 3x squared, I'll have to do 3x times 1x. To get 1, I'll have to do 1 times 1. And then since these are both positive, these must both be positive as well. 4 terms. When you have 4 terms, you always use the method of grouping. So I take the first 2 and then the second 2, and I factor out the GCF. So in the first group, I have a GCF of A. I'm left over with B minus 3x. In the second group, I have a GCF of 2x. and then I'm left with b minus 3x. Notice that these groups are exactly the same. They must always be that way. If they're not, check your work and change things so they are exactly the same. Now I put them together, so a plus 2x is my first set of parentheses, and b minus 3x is in the second set of parentheses. You could check your work then and notice that when you do the first, you get AB. The second, you get the outer is negative 3AX. The inner is plus 2BX, and the last is negative 6x squared. The last factoring problem. Oh, check for the GCF. Sure enough, there's a GCF in this problem. There's the number 2, and there's also the variable x. So factor out 2x, and then I'm left with x squared minus 25. And remember, we're trying to factor completely. This portion can be factored again. It's the difference of perfect squares. So I write the 2x, and then I have my two sets of parentheses, x and x. And then to get 25, I'll use 5 and 5, but 1 is positive and 1 is negative. 5 times negative 5 is 25. Negative 5x plus 5x cancel out. Good luck in factoring.